Hi everybody, I'm Jason. Today we're going to take a look at our storage calc application that we picked up from GitHub, and we're going to turn it into a true MVVM application. So the very first thing we need to do is import a couple of NuGet packages. One of them that I've come to like is from Microsoft, and it's the Toolkit MVVM package. And so we'll get that installed. And then I think I want to do some dependency injection just to kind of start to make this a little bit more of a solid application. So let's grab that as well. Good. Now that those are installed, the very first thing we need to do is turn the main window view model into an actual view model. Currently, if you remember, it's not being used like a view model. It's just being instantiated inside the code behind. And then, for instance, when the button is clicked, it's just calling a function on the button. There's no commanding or anything like that. So we need to make properties and commands for all of the items on the form. So if we go look at the form, we've got two inputs. We've got a series of radio buttons. We've got a button and then two outputs. And so this would be a property, this would be a property, and both of these would be bound two-way. All of these would be properties, although we'll address that in another video. We have kind of an open-close principle concern here. The button would be bound to a command, and then these would be read-only properties or some sort of output property here for the usable space and the fault tolerance. So let's go ahead and get at that. So in the main view model, we're going to need to create those properties, and I won't make you watch me create those. I have those pre-made, so let me grab those here, and we'll walk through them together. And so we've got disk count, which is an input. We've got disk space, which is an input. And we have RAID 0 through RAID 10, which are all inputs. Those are the radio buttons. And then the total space text is going to be more or less a read-only property. And then the fault tolerance text is also going to be pretty much a read-only property. So these technically could be set to private, but at this point we'll just leave them the way they are. And then this relay command here is going to be what happens when the button gets clicked. Okay, so let's go back out to the top. Obviously we're using a method called setProperty that's coming from that NuGet package that we downloaded. So what we need to do is we need to inherit from a class, and that class is observable object, and that is more or less the base class, if you will, for something that has properties that need to let the view know that their property has changed. And so you could think about it kind of like a base class for your view models. Obviously, you could take a base class or make your own base class and inherit from observable object if there were other common things that you needed to do in all of your view models. But for now, I think for the scope of this application, I think that's going to be good enough. And then the other thing that we're missing is the relay command that's also coming from a Microsoft namespace. So we'll grab that. And then I think we're ready to rock there. Okay. The only other thing we need to do is this relay command isn't really doing anything at this point. It's just sitting there uninstantiated. And so we need to add a couple things here. If you're not familiar with commanding in the MVVM pattern or in WPF in general, there's typically two pieces to a command. There's a piece that says, can I execute the command? And another piece that says, what happens when I do execute the command? And so we need an extra method, and that extra method we're going to call can calculate, and I'm just going to put that above calculate there. And then we're going to say our calculate command, and then here's where we name our can calculate. Oop, I got that backwards. Calculate and can calculate there. Okay. So when it needs to check to see if it is able to calculate, then it's going to call this command or call this function. And if it's going, when it actually does want to calculate, it's going to call this function. Now you'll notice we have all these properties that are going to be bound to the UI. A lot of those are duplicates of what's being passed into this function. In fact, all of them are. And so what I'm going to do is delete all of the arguments out of this function. And then, let's see, I don't think we need to keep a whole lot of this. we're not going to need to cast because our properties are all already numeric values, and so we're not going to need to cast. So that solves that problem. It also solves the problem, remember the catch down here, all it was doing for us was catching invalid user input. And so the framework is going to take care of that, make sure that the values are numeric. And so we're not going to need to necessarily try catch here. So it eliminates that. Disk space is now going to be our property, and all of the RAID 0, RAID 1, etc., those are going to be properties as well. So let's set that to that. And that's kind of redundant. That's kind of a silly thing to do with a non-nullable. And so we'll just get rid of that and use kind of shorthand there, because if it's true, it's going to return true. We don't need to check to see if it is equal to true. And so our disk count is going to be our property. Fix that up there as well. Okay, clean that up. Disk count is a property. Disk count again. Okay, clean this up. Disk count is our property. So like I said a little bit earlier, we do have a little bit of an open-close principle issue here, where let's say if somebody did add a new type of RAID array in the future, we would have to come back in and we'd have to modify this class. We'd have to modify our view model to accommodate our new type of RAID. And not only that, we'd have to modify our view so that it was aware of the new type of RAID as well. And so that open-close principle can get you in trouble if you sort of overdo it. However, I think what we'll do is a little bit later, we'll come back and we'll fix that open-close principle issue here. For now, we're going to call this good. The other thing is this function is no longer going to need to return anything. It's going to need to set the output properties. So our total space text and our fault tolerance text here are going to need to be set. And so we're not going to need to return anything. So this is going to be void. And we're not going to need to return default of anything because there's no tuple to return. Get rid of that. Okay, and then down here, we're going to, instead of returning the tuple, we're going to say our total space text is equal to this here. Okay, and then our fault tolerance text is going to be our fault tolerance. Okay, so I think that's pretty much done. Now you can imagine we've broken a lot of tests over in our test project. And so let's go over and see how we can fix those. So if we were to actually try and build this test project, it would obviously fail because our calculate method has changed. So let's think about how we can fix these tests. I think we're probably going to need to change these to numerics. So these are no longer going to be strings here. So we'll change those to numeric values. These are our disk count and disk size. And then we don't have nullable booleans anymore. So I think what we'll do is we'll pass false in instead of null. And so we'll just do a quick null, change it to false. Okay. And then our outputs should remain strings. And obviously we're going to still behave with a localization, and so we'll keep that as well. What I'd like to do is utilize our new command as well instead of calling the function directly. And so typically what you'd see in a view model is that this function would be private. And then the only way to access that function is through the command. And so what I'd like to do is change this to an integer. Our disk space is going to be a double. And we've got some kind of funky argument names just when we refactored the first time. Obviously, these are not going to be bool question marks anymore, so let's replace bool question mark with bool. Okay. Perfect. All right. And then we're going to set our localization, and we're going to set some things on our system like the disk count, the disk space, and we're going to set all of our RAID variables. So that pretty much takes care of our setup there. Now we need to call our command, and so we're going to say if calculate command can execute, and it always requires a parameter. In this case, it's going to be null, and then we're going to say calculate command execute and pass in the same parameter, which is going to be null. Okay, and then our tests are not going to check the output anymore. They're going to check the property on the view model, which is the total space text and fault tolerance text. Okay, and then we're going to have to make those same changes for the other inline data test here. So we did have a couple of tests that tried to get us code coverage for the catches when we did pass in bad data. We're not going to be allowed to pass in bad data anymore. So anything that's larger than integer max or anything that's an actual alphanumeric, those tests are not going to be needed anymore. So I'm going to go ahead and delete those. So I believe we fixed our tests. So let's go ahead and see if this will run. And we're going to run tests. Oop, looks like something else is broken. So let's go take a look at that. Okay, so our button is going to be broken as well. So we're not testing the UI quite yet, so we're going to comment that out. Now let's go ahead and run the tests again. All right, looks like we got all green there. All of our logic has remained the same. The view model is behaving as we would expect now that we've refactored it a little bit. Now, the last part to make this an MVVM application would be to switch over to the main window view model, or I'm sorry, switch over to the main window. And now we need to do some binding here. Our text box for the disk count input is going to be bound. Let's put that here. So text equals binding. And let's go grab the name of our disk count property to the disk count. And we're going to bind that in a two-way mode. And the same with the disk space. Let's grab the name of the disk space. Okay. And then each of our radio buttons is going to be bound to its own property as well. And we're going to do that with the isChecked property. And so these are all named RAID and then the number. So capital R, RAID 0. This is going to be need to be bound two-way as well because we need to write back from the UI. Okay. And then our calculate button is no longer going to have a click event, or a click event handler, I should say. And instead is going to be bound to a command, and that's the calculate command. Okay. And then our output text blocks are also going to be bound. So their text is going to be bound to these properties down here. So total space text, which is this one. This one is going to be fault tolerance text. All right, just a couple more steps and then we've got this turned into an MVVM application. So one more thing we need to do is we need to actually bind the view model to the data context of this window. And what we'll do with that is we'll go over into the app config, or not the app config, the app XAML CS. And you can see where we're setting our current culture here from a previous video. And what I'd like to do is introduce a little bit of dependency injection, and maybe I'll do a separate video on dependency injection, how it works. But the basic idea is that anytime we need a dependency, we're going to ask this framework to give it to us instead of having to instantiate it ourselves. And so let's go ahead and pull in our references there. So what this is saying is, okay, IOC container, the inversion of control container, I want to configure these services here. And the very first service we're going to have is the iMessage box helper. We created that in the very first video as a wrapper for the message box. We're going to add the main window view model as well, and that's going to be put in as a singleton, so there's only ever going to be one of those that's created, and we'll reuse that same instance over and over again. And then what we're going to do is go over and create something new in the view models called a view model locator. And so we'll say view model locator here. And this is going to be a very simple class that's just going to ask the IOC container to go ahead and give us an instance of a view model that we're interested in. And so let me paste this in here. I had that made already. And we need to include the IOC library there. And so all this is doing is it's saying, I want to create a property. And when somebody gets the value of my property, go and get the main window view model. So main window view model property is going to return an instance of the class main window view model. And what that's going to do for us is in essence give us a singleton that we could reuse throughout the application if it ever got bigger or ever needed to have multiple windows or that sort of thing. We would only ever have one instance of that created. And it also allows us to bind. So let's go ahead and set something up in the actual XAML here. We're going to create a resource for this view model locator. And so to do that, we need to import a new namespace, which is our view models namespace from our project. And then we're going to say VM view model locator, and we're going to give this a key of view model locator. And then what we can do over in the main window XAML is we can say, it's a little bit of a complex string, so I apologize. I'm going to have to paste it in here. So we're going to set the data context to the main window view model property of the static resource view model locator. That static resource is what we just declared inside of the app XAML. So that's what that is there. And then the main window view model is the property on our actual view model locator from here. Okay, and so once we've set that data context, now when we, looks like I'm missing something over here. Yep. Now when we run the application, we should see our text boxes are already filled with 0 because the default value of integer is 0. And same with the double type, which is our disk size there. And then all of these radio buttons are set up to bind as well. So let's go ahead and put some data in here. Now you'll notice when I click, I can't click on the calculate button. The reason for that is because back in my view model, if you go look at the can calculate method, it depends on all of these properties. So disk count, disk space, RAID 0, RAID 1, RAID 5, RAID 6, and RAID 10. The button doesn't know the dependency that this command has on those properties. And so we have to let the button know that it needs to reevaluate whether or not it can execute the command whenever any of these properties change. And so the way we're going to do that is we're going to override a method, override, if I could spell, on property changed. So when any of our properties change, and this is coming from the observable object that we inherited from, when any of these properties changed, I want to say calculate command, and then I'm going to say notify can execute changed. And that's going to let the button know, it needs to reevaluate, it needs to recall the can execute function on the command, which will in essence execute this can calculate function, and it will reevaluate all of these. Because what we're saying here is the disk count has to be greater, the disk space has to be greater, and then one of the RAID buttons has to be checked. And so when it instantiates, it says, none of that is true, therefore I can never execute. And it doesn't know it should go reevaluate that. So we've let it know it can reevaluate that, or it should reevaluate it. So now if I type in the same values I had and I hit RAID 5, boom, calculate lights up. I can click calculate, and then I get my result there. Okay, I can change that, change to that. And then if I have something that's incorrect, I still get my message box. In summary, what we've done is we've introduced MVVM. We've also introduced IOC, inversion of control, and a dependency injection framework. And that has allowed us to eliminate a little bit of code inside of our main window view model. As a side note, this is a big code smell. If you have a bunch of if statements or if statements inside of if statements, that is typically an open-close principle issue. And so you probably want to take care of that in your code just to make it better. There's a couple different ways you could probably fix it. Probably one of my favorite ways is to take, especially with this particular type of violation, what I'd like to do is wrap, if you notice, RAID 0 does its own calculation, RAID 1 does its own calculation, RAID 5 does its own calculation. So maybe wrap them into their own calculator classes, and then have a collection of those classes that is at runtime pulled up, so that if we ever did add a RAID calculation that was different than this, we could just add that into the namespace and then have it pull up automatically. So what I would like to do in the next video, as we make this project better, is to fix that open-close principle problem. So stay tuned for that video coming up next.